This seventh lecture on Fortran. Today we shall discuss what is known as array variable. Array variables. In mathematics, we sometimes encounter quantities like xi. That is, we want to denote quantities like x1, x2, up to xn. These quantities can be written in Fortran like this. This x1 is written as x1 and this is x within parenthesis 2. So this x1 stands for this, but we have to specify at the beginning of the program that we are dealing with a quantity x which can have more than one values. So what we do, we first write dimension blank a quantity x within bracket. If we write 10, that means since the variable name starts with x, so it is a real variable, and x, the variable x can have 10 values. The values are x1, x2, x3, x4 up to x10. One must be very careful about assigning this dimension, this space. When we write in this fashion, during the execution in RAM, 10 allocation units are allotted, 10 units of memory are allotted to the variable x, real variable x. If you provide values of x less than 10 means 10, so if one may use only x1, then what happens, out of 10 locations only one is filled up and the 9 remains the empty. If you use x4, then x4 will be allotted in the 4th location and the first 3 and the other 5 to 10 location will remain empty. But a problem arises if one assign x11, say x11. So at the beginning of the program we have said that, taking this one as the example, that x is a real variable which can have at most 10 values, and we are providing x11 which is in direct contradiction with this. So this, in such a case where a compiler may give you a message that overflows, means there are 10 locations for x and you are assigning a value to be placed in the 11th location, so there is no provision for this. So it may give you an error, that is overflow error. In Linux or Fortran compiler, operating system gives a message code dump, and it occupies a large space. And there are some other compilers which cannot take into consideration the bugs of the problem. Then it may continue calculation, but the result will be an erroneous one. Before proceeding further with the dimension, let me take an example, simple example where we can use this array variable. Say we have two vectors in 3 dimensions, vector A and B. If we consider A dot B, we know this is A1 B1 plus A2 B2 plus A3 B3. So we are trying to write a program which will read the vector A, that is A1, A2, A3, and the vector B, that is B1, B2, B3, and calculate the dot product. So what should be the program? Let me first write the program, then I will explain. At the beginning, first we write dimension. This dimension statement has to be written before any executable statement. So dimension A within bracket 3 comma B within bracket 3. Since both the variable names are starting with A and B, so they are real variables. That means A is a real variable which can have at most 3 values, and B is another real variable which can have 3 values. So the next part would be to write A1, A2, A3. One way of writing it is that write star comma star A1 comma A2 comma A3. But if you have a large number of data, then it is not a practical way of writing this. Furthermore, if you have, say, A may have other values, say A may have 10 values or A may have 100 values, then it is not practicable to write these one after another separating by comma. Instead, we can write it as, this is an equivalent statement. For this part, we write AI comma I is equal to 1 comma 3. Here there is no I is a dummy variable which has not been assigned I earlier, so it assumes that it is a loop variable, and this loop variable I takes the value from 1 to 3 in steps of 1, so it actually executes this one. This is called implicit do loop. Earlier we have encountered explicit do loop, which starts with do blank serial statement number blank dummy variable and its initial value, and it ends in this. In this case, these do loops are executed along the vertical direction. This is known as explicit do loop, which we have learned in the last 2 classes. So it is an explicit do loop, and this is an implicit do loop. Implicit do loop acts along the horizontal, that is along a line, and it acts across the line. So this is the one way of writing this. Another thing is that you can generalize this. If you write read n, then you can put it up to 1 to n. So you can write any number of read any number of quantities in this fashion. So I would prefer to write it in this way. So this is AI is equal to 1 comma 3. If you need to write A1, A3, A5, then call 3 followed by 2 comma 2. Sorry, it should be read first. Sorry. And then we write it writes first A colon a blank, and then it will write the values of A1, then A2, A3. It's a dummy variable. So here we have used the dummy variable as I, here the dummy variable is J. Similarly, then read Now, what we have done, this is we have read vector A and the components of vector A and the vector B, and we have also written them. Then we are to execute this part. This is summation over AI BI. So first we must initialize. So we initialize at dot is equal to 0.0. Then a do loop, do blank 5 blank k is equal to I is equal to 3 dot is equal to dot plus AK star BK, and then within 2 to 5 column 5 continue. Then write then first come to the first line. It tells the computer that there are two array variables A and B. A can have at most 3 values, and so for B. Then we write in the input statement, the program reads the value of A1, A2, A3 during execution and writes the values. Then similarly B input and output for B. Then the initialization, this sum has to be executed. So the basic logic is sum is equal to sum plus term. So this initialization is first, then dot, we have named it dot to remind us that the program calculates the dot product between two dimensional vector, and dot is equal to dot plus the term. This is S is equal to S plus T, so this is the term, and this is 5. So the up to this line this repetition will be done, and then we write the value of the dot product and the program ends. This is a simple example of array variable. I am now considering another program that calculates the sum, the average x bar is equal to xi and standard deviation. The standard deviation square is 1 upon n summation over xi upon x bar square. So I want to calculate this one first. So this is the theory part. First I write, so at dimension x, if we denote the variable by x, then it is a real variable. So first thing is that say x can at most have 100 values. You may write it for 1000, but you should not increase x arbitrarily should not increase the dimension too much, because during execution it keeps the provision for, if you write the statement like this, then it keeps 100 places reserved for x. If you increase it to say 10 crore, then 10 crore spaces will be occupied for the variable x, and if the computer doesn't have sufficient RAM space, then it may create problem, or even program may get stuck. So you set the dimension as per requirement. There are provisions in Fortran 95 or Fortran 90 which automatically adjust the dimension, which is called dynamical array. I am not going to this complicated statement. Only thing, whatever I am doing, this program can calculate the average of at most 100 terms. If you want to include more terms, then just change this line. Then second statement, read the number of data to be handled. Then it reads n data. The data are to be supplied x1, x2, x2, x3. This is along a line. Then we initialize the average. S average is equal to 0.0. Then we calculate do blank statement number 10 blank I is equal to 1 comma n. S average is equal to S average plus xi. Within 2 to 5 column, this is continue. Float n. So average x fn. Now we want to calculate this one. Then we first initialize this. Then we write another do loop. One to n. The average of x has been denoted by this. So this is xi minus avx, then its square. In Fortran there is no second bracket, no third bracket, all the brackets are only first bracket. So this is xi, this mathematical statement is xi minus x bar, and then this is square. So it performs actually this part, this summation part. And then 20 continue. Then from standard deviation is defined as this quantity divided by fn. So I keep a space. S is d divided by fn, and whole thing is square rooted. Then the output statements. One of the beauty of this dimension statement that it preserves the value of the variable. So if you ask to write what is x7, it will give you the value of x7, because the values are stored in the allocation units or in the memory unit, and whenever you call x7, then there is a allocation of x variable, and the seventh value will be dragged from there. So it also keeps the variable in memory. On the other hand, the program that we have done in the earlier case, that do I is equal to 1 to n, then read x, s is equal to s plus x. If you ask to write x, it will always write the then present value, and at the end of the loop, if you ask to write x, then it will give you the last value of x. at each and every time x is being redefined. But in this program we have preserved the individual x values in the memory, and if you ask the program to write any specific value of x, it will just bring the value from the memory allocation unit and will give you this. As the next example on the use of do variable, I am just repeating another program, that is the delta function, that is a Kronecker delta that I have evaluated in an earlier class. So we write dimension blank. We introduce d as 3, 3. This is a two-dimensional array. Earlier we have introduced a one-dimensional array by saying that x is equal to 200. We mean that x is a variable which can have at most 200 values, and they are stored accordingly. Here we have introduced a two-dimensional array. That means if we write the value as x is equal to 5, 6, that means x is a variable which can have 5 into 6, that is 30 values, and these values are stored. If we write x 15 is equal to 9, then it automatically makes it 9.0 because x is a real variable. So whenever you ask to write x 25, it will give you 0 because it has not yet been defined. But if you ask to give it x 1, 5, it will give you 9.0. Let me first do the then we write do blank 1 blank I is equal to 1, 3, do blank 2 blank j is equal to 1, 3. If I equals j, then do, and there are two do loops. So first the inner loop must be completed. Then now this program what it does, it calculates the delta function, and if I is equal to j, it assigns one value and otherwise it builds. Then we write read in this program. Firstly, it calculates all the 9 values of delta ij, of which 3 is 0, 3 is 1 when I is equal to j, and 6 are 0. And as it has been defined as an array, it preserves all the 9 values of d. delta. Say if we supply I and j is equal, both are 2, then the answer will be 2 comma 2 is equal comma 1.0. And if we say set I is equal to 2, j is equal to 3, the result will be 0. It preserves the calculates the delta from Kronecker delta and preserves it in it. And whenever you call dij, it will give you back the value. Sorry, here the spelling mistake. Please correct the spelling mistake. And another precaution that has to be taken, in the same program we cannot name any variable as d, because d has already been assigned as a array, two-dimensional array. So any other variable, if we write d is equal to say b square minus 4ac, in the same program it will give you a warning or error message, because this statement says that d is an array variable. So whenever you write d, its argument has to be written, but here there is no argument, so it contradicts. Here we have assigned d to be an array variable, and here it is not an array, so it will give you an error message. This precaution has to be taken. If situation arises to introduce such, then d1 or something may resolve the problem. The array variables, these two-dimensional arrays, are extensively used in the matrix operation, which we shall take up in the next class. We shall use this concept that I have introduced in this lecture to perform the matrix operations, that is the addition, subtraction and multiplication of two matrices using do loops and array variables in Fortran.